My name is Madeline and I'm from class 9A, and today I'll be showing you 9 simple physics phenomena and explaining it scientifically. They are all related to the subtopics of our physics textbook, so let's get started. First is the unit 1.2 balanced forces. We'll put the object on both sides of the ruler, and yet it is balanced now because the forces are the same size but in opposite direction, so they will cancel out. When the forces are balanced, then its motion will not change. So if it's not moving, it will stay still like this. If it's moving, it will keep moving at a steady speed. If the forces are not equal and opposite, then they are unbalanced and the motion will change. If they are not moving like this, and they will start moving. And if they are moving, they'll start to accelerate, decelerate, or change direction. We'll go on to our second, is the unit 1.3 friction. This is a mouse pad and falling on the front side and falling on the rough side. So they are falling in different ways, and it shows the presence of friction. It is a force that slows things down. This shows that smoother surfaces have less friction and rougher surfaces have more friction. And we'll move to our third one, is from the unit 1.10, round in circles. And I have a ball attached to a piece of string, and I'll start swinging it in circles like this. So the force that keeps it moving in a circle is actually called a centripetal force, and it is Latin for the phrase center seeking. So it always points on the center of the circle. The ball has a tangential velocity, so if I suddenly cut the string, it will fly off in whatever the tangential direction was. The same centripetal force also keeps the roller coaster on the track. So if next time you're having a blast on a roller coaster, you can thank the centripetal force. And we'll move on to the fourth one, which is the unit 6.4 reflection. Looking in a flat mirror, we also call it as a plane mirror. So my reflection is an image. It's like what you're seeing now is also an image. It is exactly the same as me. We say that the image is virtual. There is no another me exists behind the mirror. So if I hold out my right hand, then the image appears holding my left hand. As what you're seeing now, I'm actually holding my right hand. The image is laterally inverted, and the word ambulance is written laterally inverted. When the driver in front reads through the rear view mirror through lateral inversion, form a right-oriented image like this. So the fifth will go on to the unit 6.6, refraction, air and water. So when I put a pencil inside the water, it looks bent, right? Why is it bent? It all has to do with the fact that light travels more slowly in water than it does in air, and that causes the light to bend when it goes from water to air or vice versa. The bending of light is called refraction. The refraction of the light makes the pencil look bent. We'll go to our sixth phenomena, which is from unit 8.2, the effects of pressure. The blades of knives and scissors are sharp. They have very small areas, so the force you apply produces a big pressure. If the blade of both become blunt, then the area gets bigger and the pressure might not be big enough to cut things. And we'll go on to the eighth, which is the unit 8.9, explaining density. Oranges. Which one you think is heavier and will sink, and which one you think is lighter and will float? I believe that everyone will say that this orange with the skin will sink, but let's see. You just place it softly. Okay, so the orange actually floats, right, with the peeled orange. So the peeled orange sinks. So why does the heavier one float and the lighter one sink? The secret to this experiment is density. Water has a density of 1 gram per milliliter. Objects will sink if their density is greater than 1 gram per milliliter. The orange with the peel floats because the peel is porous and filled with tiny air pockets. These pockets of air help increase the buoyancy of the orange, helping the orange become less dense than the water. On the other hand, when you remove the peel from the orange, you are in fact making it lighter, but you are also removing those tiny air pockets. Therefore, The peeled orange is denser than water and it sinks. And we'll go on to our ninth phenomena and experiment, which is the unit 9.1 electrolysis phenomena. I'll have a plastic ruler, pieces of paper. When I rub a plastic ruler against my dry hair, and see, it attracts pieces of paper with an electrostatic force. Initially, the plastic rulers was electrically neutral. Hence, it did not have the ability to attract the pieces of paper. But when I rubbed the ruler against my dry hair, I charged it. Once it got electrically charged, it got the ability to exert a force on the pieces of paper and attract them. This is the end of my video, and I hope you have learned something today. Thank you so much.